The Royal Thai Air Force exhibits modernized F-5 Tiger II warplanes. The modernization project of 14 fighter planes from Squadron 21, Air Wing 221 Ubon Ratchathani was carried out by Elbit Systems Israel and the aerospace industry of Thai Aviation Industries, Thai. The F-5 Tiger II, which underwent an upgrade, seemed to get a total change in the camouflage color scheme, as well as getting a new name, being the F-5TH Super Tigris, is now armed with Iris-T short-range air-to-air missiles. The F-5TH Super Tigris will also be able to use beyond visual derby missiles made by Rafael Israel. The F-5TH Super Tigris has also been grafted on targeting devices, including Litening III by Rafael and the ability to fire Lizard laser-guided bombs made by Elbit Systems Israel, coupled with electronic warfare devices made by Rafael Sky Shield and tactical Link developed in Thailand, making the F-5TH Super Tigris now has the ability to be equivalent to a 4.5 generation fighter like the Gripen C fighter aircraft, also owned by the Air Force Thailand. The F-5 Tiger II is part of a family of supersonic light fighters, originally designed in the late 1950s by Northrop Corporation. Being smaller and simpler than contemporaries like McDonnell Douglas F-4 Phantom II, the F-5 was cheaper to buy and operate, making it a popular aircraft. The F-5 began as a light combat program privately funded by Northrop in the 1950s. The design team wrapped a small aerodynamic fighter around two high-pressure General Electric J-85 engines, focusing on performance and low maintenance costs. Although primarily designed for the role of daytime air superiority, this aircraft is also a capable ground attack platform. F-5A entered service in the early 1960s. During the Cold War, more than 800 were produced until 1972 for U.S. allies. Although the United States Air Force (USAF) did not need light fighter aircraft, the U.S. bought around 1,200 Northrop T-38 Talon trainer aircraft, which were directly based on the F-5A. After winning the International Combat Aircraft Competition, a program aimed at providing effective low-cost fighter aircraft to the American allies, in 1970, Northrop introduced the second-generation F-5 Tiger II in 1972. These improvements included a more powerful engine, material capacity, higher fuel levels, greater wing area, and improved front edge extension for better turn rates, optional air-to-air refueling, and improved avionics including air-to-air radar, mainly used by American allies, remains in U.S. service to support training exercises. It has served in various roles, capable of carrying out air and ground attack tasks. A total of 1,400 Tiger II were built before production ended in 1987. More than 3,800 F-5s and closely related T-38 trainers were produced in Hawthorne, California. The F-5 and F variant operates with the United States Navy and United States Marine Corps as enemy trainers. Around 500 aircraft were operated in 2014. The F-5 was also developed into a special surveillance version, F-5TH. The F-5 also serves as a starting point for a series of design studies that produce Northrop YF-17 and F-A-18 naval combat aircraft. Northrop F-20 Tiger Shark is a sophisticated variant to replace the F-5E, which was eventually cancelled when export customers did not appear. The design effort was led by Northrop Vice President of Engineering and Aircraft Designer Edgar Schmood, who previously at North American Aviation had become the successful chief designer of the North American P-51 Mustang and F-86 fighter aircraft. Schmood recruited a strong engineering team to Northrop and assigned them the goal of reversing the trend in the development of fighter aircraft towards greater size and weight to provide aircraft with high performance, enhanced maneuverability, and high reliability, while still providing the cost advantage of fighters contemporary. Recognizing that expensive jets cannot be replaced every few years, he also demands engineered growth potential that allows long service life of more than 10 years. Schmood acknowledges that new jet engines and aerodynamic technology are essential for these purposes, such as the ratio of General Electric J-85's turbojet engine, which is concise but high, and the rules of the newly discovered transonic area to reduce barriers. The J-85 engine has been developed to power McDonnell's ADM-20 quail feed used on the Booth B-52 Stratofortress. This engine, with a thrust-to-weight ratio of 6.25 to 7.5 in various versions, has a prominent push-per-pound advantage over contemporaries, such as the 4.7 to weight ratio of the J-79 engine used in the F-4 Phantom. Another very influential figure was Chief Engineer Welko Gazek, who convinced Schmood that the engine must be inside the fuselage for maximum performance. Gazek also introduced the concept of life cycle costs into the design of fighter aircraft, which provided the foundation for low F-5 operating costs and long service life. A Northrop design study states the application of advanced technology is used to provide maximum force effectiveness at a minimum cost. This is Northrop's philosophy in the development of T-38 and F-5 light trainers and light fighters.